Hello students, I am Professor Pragati Mahale from the IT department of ASSMS IOIT, and today we are going to study the topic from Unit 1 of Theory of Computation from the course T Information Technology. The topic is Finite Automata. So let us see the introduction to finite automata. A finite automata, also called as finite state machine, it is a mathematical model for the process with input state, output states and set of transition from the state to state that occurs on a given input symbol from the set of alphabet called as sigma. So finite automata are used for solving several common type of computer algorithms. Let us see some of the applications. It is used to design of a digital circuit. Then finite automata can be used for string matching, communication protocols for information exchange, lexical analyzer of a typical compiler. Let us see some important terms involved in the finite automata. First is alphabet, and alphabet is a finite non-empty set of symbols. Okay, the symbol sigma is used to represent the alphabet. Common alphabet includes the set of binary alphabet having 0, 1. Then this is the another example, which is a set of uppercase letters. So we have A, B to up till Z. Next term is word. It is a finite sequence of symbols from the alphabet. For example, apple. So this is a string which is taken from this set of uppercase letters. A string with no symbols at all is called as the empty string, and it is denoted by the symbol epsilon. The length of the string is the number of positions for the symbol in it. So the standard notation for the length of the string W is nothing but writing W into 2 sticks. So here we have W having 5 binary numbers. So the length is 5. The set of all the strings over the alphabet is denoted by alphabet closure or star, which is the union of different inputs with empty string, a string of length 1, string of length 2. So it can be written as the symbol sigma closure or the star, which is a set of the strings having epsilon, strings of length 1, 0, 1, string of length 2 like 0, 0, 0, 1, 1, 0, 1, 1. So 4 combinations we can have, and so on. Next is the term language. So language, it is a subset of strings over the alphabet. It any subset of sigma closure is a language. A sigma is the alphabet and L is the subset of the sigma closure. In that case, L is a language over the input set. So here, for example, let us see L1. It is a language over the alphabet set 0, 1, and it has all the strings having equal number of zeros and ones. So here we can write the set as L1 with, it is a star here. That means we have 0 or more occurrence of the 0 and 1. So empty occurrence, 0 occurrence is indicated by epsilon, comma, 0, 1, the string of length 1, string of length 2, and so on. We have equal number of zeros and 1s. So you can see here in every input there is equal number of 0 and 1, equal number of 0 and 1. Thank you.